Hi guys, coming to the second design pattern. This time we are going to learn another design pattern which name is template method pattern. This pattern is very similar to the previous one which we have learned in first tutorial, the strategy pattern. So try to recap a little bit about strategy pattern. It is about exposing the responsibility of creating the object in subclass, right? So for example, we have a wing, and this wing will be instantiated in the subclass. So you are free to choose which wing you want to have for your subclass. So this is for the strategy pattern. So what is the template method pattern? So try to imagine if you have an algorithm, a series of steps you are going to take in order to achieve something. So this time, you are not exposing the entire responsibility to the subclass. In fact, you are only exposing several steps. So for example, try to imagine the sorting algorithm. First, we'll compare A and B. Then we'll do a sorting, for example. So you are exposing the responsibility of comparing object to the subclass. So they have to implement it in order for you to complete your sorting. But they don't have to know anything about the sorting algorithm, because you are only exposing the responsibility of comparison to the subclass. So this is equivalent to what we are doing for the standard library. So try to imagine, for example, if you have a class, a custom class, which name is player, and you are going to sort an array of player. In that case, the array of player you are not able to sort yet using the standard library unless you implement the comparable interface, right? So in that case, implementing the comparable interface and overriding the compare to method is mandatory for you to complete the entire algorithm. But you are not required to know anything about the sorting algorithm itself. So this is called template method pattern. We'll use the RPG example again to showcase how to use the template method pattern and what is the difference between the strategy pattern which we learned before. So now we have the parent class, which is the abstract class, player, and there are some attributes here. So we have it attack, defense, and as well as the magic. So these are the values. And we have a flyable, which is the wing. So this is exactly the same as what we have done previously. We are using the composition to compose the wing instead of using the inheritance. Well, basically that is it. So what we are going to do here is that we have two abstract method which is going to be implemented in the subclass. So I am not going to use so many class. Yeah, we are going to focus on the human race only. So now we have this tool to be implemented in the subclass, as well as we have an ultimate combo attack. So try to imagine if you are playing the Street Fighter, for example. Yeah, in order to execute the ultimate combo attack, you need to press some fixed sequence, right? So for example, up, up, down, kick, punch. They will execute one ultimate combo attack, which has a absolutely high damage. Yeah, compared to a normal attack. So this time we are going to simulate that particular ultimate. So, for example, in order for any player, regardless what race you are human, you are angel, you are devil, if you want to execute the ultimate combo attack, you need to punch one time, then kick one time, and you need to execute the spatial attack 1, and you need to execute spatial attack 2, then punch again, yeah, for example. So this is the sequence that you need to do in order to execute the ultimate combo attack. So what we are going to do here is that we are going to calculate the total damage for the ultimate combo attack. So for example, so initial damage is punch one time plus kick. So as you can see here, every attack that you are executing will return an integer. It's not going to be an integer, definitely. Then yeah, it's going to be a double. Yeah, so this is it. So our initial damage will be the summation of all these attacks that we are executing, as if we are executing them one by one. So now we already have the initial damage, but since we are ultimate combo attack, right? So this damage will be scaled up if we are using this particular combo. Makes sense, right? So this is final damage equals to initial damage times, let's say, okay, we have a scale up of 1.5 damage, and I'm going to print out the ultimate combo due no, I'm going to use a printf. So printf and %.2f damage. So this will be our final damage, and we are going to return the final damage as well. So basically this is our combo attack. First, combine the punch, kick, special attack 1, special attack 2, and punch. And this will be the initial damage and scale up by 1.5 and print the ultimate combo damage up and return the damage afterwards. But now we are lacking of two things, right? So this is the parent class and it's an abstract class. Now we are not yet implementing the special attack 1 and special attack 2. So this is the template method pattern. The parent class itself are giving the responsibility of implementing the special attack 1 and special attack 2 to the race that extends the player class. Well, let's say we have the human now, right? So the human is extending the player. So we need to use the special attack 1. We need to implement all these two methods first, and print line human special attack 1 body smash. Never mind lah. Okay, so this is the special attack 1 for human, and I will return the fixed damage. So for example, the fixed damage is 5. Yeah, and now special attack 2. I need to implement these two, else I will return a compilation error, right? Because these two are not yet implemented in the parent class and it is abstract. So human special attack 2. I love to use a game as an example because I personally am a gamer. So I will return the attack times 1. So this will be scaled up with 1.0. It's exactly the same as the attack that the parent currently have, which is 10. Now we have a special attack 1 and special attack 2 ready now. Now we try to create an instance and see if I can do a ultimate combo attack for the player. So right now I'm using a double, but I don't think I need a double now. So I'll just do a void and no need to return anything. So now player equals to new human. Now we have a new human as a player, and I want it to execute the ultimate combo attack without any parameter. Let's try to run it. Cd desktop, cd java project, and we'll go to the template method pattern. Now, as you can see, this is the ultimate combo attack. First, I will be punching first, and oh shit, okay. So first I will be punching, then secondly I will kicking and executing the special attack 1, special attack 2, and punch again, and deal the damage, which is the scale up of 1.5 from the initial damage. So we are done. So this is the template meta pattern, which we are using the subclass to implement the special attack. So what else we can do with the template meta pattern? So there's a reason why I'm using a flyable here, which is a wing. So let's say now we are going at advanced mode where human can also equip with wing, and they are able to fly with when they are executing the ultimate combo attack. So what we are going to do here is that, so this is the variation which you can do for template meta pattern. can fly, return false. So now we have a boolean which will always return a false in the parent class. What can this do? So for example here, if I use a if condition in, so this is like a flag which we are putting in the ultimate combo attack, that if the player is able to fly, I will be executing another damage which will scale up again our damage plus the flying damage, which is for example like 50. So ultimate combo with wing with flying attack. So this will be a flag indicating that, oh, if the player is able to fly, I will be summing with the constant value of 50, as well as to print a different flying attack that further scale out our ultimate combo attack. Else, I will just print the initial final damage. So this boolean will be the indicator to show us, oh, whether I can fly or I can't fly. And by default, the player is not able to fly. Now here comes a magic thing. As a human, if, let's say, if I want it to be able to fly, I can actually override the flag. So, and the way I override is not necessarily just, oh, I will return a true, so I will keep going into this condition. Yeah, it depends on the use case. But not only you can do this, but you can also do something like, oh, if my hash p is, yeah, if I don't have any hash p, so let's say if my magic is greater than 5, I will return a true. So if I have enough magic, and then I will return a true. And not only that, well, let's see. If my magic is then magic need to minus 5. Else, I will return a false. So this is the variation which we can do for the template method pattern, which this ultimate combo attack will decide whether they will execute this operation or not based on the flag, and we are free to override the flag by any condition by simply overriding the parent method. So by using this, I'm able to see a different behavior for the player. So let's say I execute 4 times ultimate combo attack. Let's see if he is able to achieve that. Oh shit. So javacmain.java and java main. Well, it's pretty long, but we can see one by one. So first of all, it is using the flying attack, and second, it is still using the flying attack, but starting from the third one is using the normal damage only. Why is it happening? Because the magic itself by default is 10, right? So it comes to the subclass here. So by default is 10, so it is achieving the first condition, so it will return the true. But the magic is reduced by 5, since we have used a flying attack, which is much more powerful, right? And the second time also the same. It will reduce the magic to 0, and starting from the third one, it is starting to fail the condition, so it will return a false. And no matter how many times afterwards I tried, I was still returning a false. So this can make us more flexible in terms of setting the behavior of particular algorithm. Well, that's it for the template method pattern. Let's recap what we have learned about this. So, template method pattern is simply an algorithm, and part of the algorithm we are providing the responsibility to the subclass. So we are using the abstract method to abstract out several methods and let the subclass to decide what behavior they want to have for that methods. So another thing is that we are using a flag to identify the behavior of the algorithm itself, and this flag has another name actually, which is called hook. So this is a hook which decide whether I should move into this operation or not. Well, let's see if I miss out anything here. Well, there's a very interesting principle which is called Hollywood principle that this template method pattern implements. And this Hollywood principle means don't call us, we'll call you. So whatever, as you can see, as a human, you only know how to override these two methods, right? But you are not knowing the exact black box for the ultimate combo attack. Yeah, you're not knowing. You don't actually know what it is, how it is executed. So this is the black box, and human itself has no responsibility or has no authorization to call the special attack 1 and special attack 2. So this is the how it call, like whenever you want the ultimate combo attack, yeah, the responsibility itself still goes to the parent class, and the subclass only knows to implement several steps. So this is how we call as the don't call us, I will call you. Yeah, so the parent will call the methods from here. Yeah, instead of directly calling it. Let's say this can also be like private, right? So if we are setting it private, so they cannot be standing alone. They need to use the parent method ultimate combo attack in order to be executed. That's it for the template method pattern. Quite some important terms I have been mentioning. Again, I will be putting this into GitLab so you can refer to it. Like if you have any problems, yeah, feel free to discuss together with me. That's it. See ya.